Welcome to Hartman Math. This is lesson 6.2, inverse functions. We're going to begin with example number 1 with a function, and we're tasked with finding its inverse. So here are the steps. Step 1, change our function notation f of x and just replace it with the equivalent y. So we wrote it as y equals. Step 2, switch all the x's and y's. So the y becomes x and the x becomes y. If there are more x's, all of the x's become y. Now we're going to solve for y. So that's step 3, solve for y. We're going to get the y by itself on the right. So we should probably undo the minus 2. We're going to add 2 to both sides. And then we've got to get rid of the 3. We're going to divide by 3 on both sides. And we've got the y by itself. Step 4, once we've done that, is to convert back to function notation, but indicate that we found the inverse. So it would be f, and it looks like an exponent of -1, but since f is not a variable and cannot have a value, it's really just notation. So it says f, and it looks like an exponent of -1, but we say f inverse of x, or the inverse of f of x. So we write it f inverse of x is equal to the x plus 2 over 3. And those are the steps to finding the inverse of a function. All right, so go ahead and pause the video here and go ahead and you find the inverse function for g of x. In the end, make sure we write it in that inverse function notation. All right, let's go ahead and take those steps. We're going to write it as y equals. We're now going to switch the x and the y. Let's go ahead and solve for y. So we'll subtract 7 on both sides. Now to undo the 1/2, probably our best bet is to multiply both sides by the reciprocal. And on the left side, that is going to distribute. So 2 times x minus 7, as we distribute the 2, we're going to get g inverse of x is equal to 2x minus 14. Example number 2, let's do this again. Let's find the inverse of this function, h of x. Step 1, y equals. Step 2, switch the x and the y. Step 3, we're going to solve for the y, so we'll add 2 to both sides. Now, how do we get rid of the exponent? How do we undo cubing? Let's take a root. Let's take the cube root on both sides. Since it's an odd root, no need for plus or minus. There we go. We've got the cube root of both sides. And now we can rewrite it back into function notation. H inverse of x is equal to the cube root of the sum x plus 2. All right, the next thing we would want to do besides being able to find an inverse is to verify or prove the two functions are inverses. And we do so by the definition here. Two functions f and g are inverses if and only if, and this is the abbreviation for if and only if, meaning the if-then statement runs both directions. If and only if, when you do the composition of f composed with g of x, you get an answer of x. And when we reverse that, g composed with f of x, you also get an answer of x. So this definition is going to be how we verify the two functions are inverses. We're going to do both compositions, making sure we get an answer of x. So example number 3, we've got these two functions. We're going to verify, we're going to prove that they are inverses. We're going to start with f of g of x. I call this the title. It is mandatory. You cannot just start by plugging in functions because I'm not going to know which one you started with. So, got to have a title. It doesn't matter if you start with this one or the reverse. We're going to have to do them both anyways. So notice we've got f on the outside. We always start on the inside g of x is right here, so we're going to replace g of x with 3x minus 5. And now that gets plugged into f, which is right here. We got this fraction, 3 on the bottom. We're going to replace the x with this. So 3x minus 5 plus 5 all over 3. When you get to here, we're going to simplify, but we can only cancel things one at a time. So you can't do all the cancelings at once. And in this case, we want to simplify above and below fraction bars. So ignore this. Look here. What can we do here? The parentheses don't mean anything. So the minus 5, the plus 5, that just becomes 0, gone. We're going to get 3x over 3. And now 3 divided by 3 is 1, so we got 1x, which we would just write as x. So essentially those 3's cancel, and we get equal to x. And that was our goal all along, equal to x. Now let's do the other composition. So let's switch it around, g of f of x. So we're going to replace f of x with x plus 5 over 3. We're now going to plug that into g, so it's 3 times, and then whenever we see an x, throw away the x, replace it with this. So 3 times this minus 5. And in this case, 3 divided by 3, that cancels first. We're left with x plus 5 minus 5. Those cancel, and we're equal to x. So I kind of check all the steps here. And what I really focus on is what do you have right before this x? And we need to see this right here. If we compare that back to the one that we just did, they shouldn't look really, really similar. They should look dissimilar. This one looks like x plus 5 minus 5. The one we saw before was 3x over 3. If they look the same, it probably means that you did some sort of canceling in the wrong order and violated the rules of algebra. So we got x both ways. We have verified. By doing that, by the definition, we have verified that they are inverses. One other thing for inverses, if we look at them in terms of graphs, they are reflections of each other, a function and its inverse. Their graphs are reflections of each other. In this particular line, the line y equals x, it has a y-intercept of 0 and a slope of 1. So it diagonally passes through quadrants 1 and 3 on the graph. So if we have this graph shown, f of x is right here, graph the inverse, which would be the reflection in this line y equals x. So we might want to start by graphing the line y equals x. Goes through here, there's our line. It has a slope of 1 and a y-intercept of 0. So now from there we can just take each point and reflect them across. What we can also do, remember in the process where we were finding inverses, we switched the x and the y. We can do that here with coordinates as well. So if we start with this point, which is negative 2 comma 0, and reverse that, we get 0 comma negative 2. So that point reflects to here. And then this is an important point, a good key point there, which is 0 comma 1. If we reverse that, we've got 1 comma 0. So this point reflects across to here. We've got this point here, which is 1 comma 3. So reverse that, 3 comma 1. And then it is touching right up here at the top, which is 4 comma 4. So if we reverse that, also 4 comma 4, we've got a point right there. Now we just kind of got to connect these. So notice this part here gets reflected here. That's a straight part right there. This next part is straight. Now the last part's the tricky part because it's bending, and it's bending from here in towards the line. So it doesn't go this way, it's going to bend like this so that it's a true reflection across the line. So that finishes example number 4, where we've looked at the inverse in terms of a graph. And that's it for today. I'll see you next time.